Okay, good afternoon. Today we're going to be looking at logarithms. We're going to split this assignment up in 2 lectures. And as I mentioned last class meeting, logarithms are really exponents. So I want to go ahead and review 2 rules of exponents that we stated last time, but we're going to be using a lot. The first is the definition of a negative exponent. We said a to the negative n means 1 over a to the n. Okay? So 1 over a to the n is the definition of a to the negative n. So if you have a 1 over that you need to get rid of, you can make the exponent negative.
We're going to be doing more from something like this, rewriting it using a negative exponent, rather than going negative exponent to something without a negative exponent.
Which is why I wrote it like that.
That's why you wrote it like this, because we're going to be doing more of the switching fractions to negative exponents than vice versa.
Whereas the last time we were using, okay, a negative exponent means 1 over. We also said a fraction to a negative means reciprocal. I'm not sure we're going to use that today. I don't think so. Now, we also defined what we mean by a fractional exponent. We said I wrote it the wrong way. A 1/2 exponent means a square root. A 1/3 exponent is a cube root. A 1/4 exponent is a 4th root, and ... I'll say it like this. A 1 over n exponent is an nth root.
Now remember I told y'all that you need to add this to your bag of tricks with logarithms. If you see a square root or a cube root, rewrite it using an exponent. So we'll be going radical to exponent more frequently.
I should have reversed it when I was writing.
That's okay, they'll get the hang of it.
We'll use it that way. I think there's some homework problems like that the last time. Okay. And just like the last time, when I use the variable b, we'll assume it's some positive number, but not the number 1. Okay? And here's our definition of logarithm. Log, this is a subscript, base b of x equals y means b to the y is x. Logarithms equal exponents.
Write out right here, Tony. Write the definition of exponential function. Y equals, what was that? Okay. So they can see that we're looking at inverse functions. Y'all remember the definition of exponential function? It was y equals, or f of x equals, I'm going to say y equals look at that. What they've done in this definition, going from exponential to logarithmic, they just reversed the variables. The y became the x became the y. So logarithmic and exponential functions are inverses, and that will become significant eventually. But an exponent is just a fancy way of expressing a logarithm.
Let's look at this. Let's try to evaluate this logarithm. Log base 5 of 25. Using this definition, the base,
that subscript is called the base,
to this power is equal to this number. Here's what you're thinking. 5 to what power would give us a 25? This statement can be written in two ways. You have the logarithmic statement, the exponential statement. They mean the same thing. People have seen exponents more than logarithms. So let me go ahead and write this as I would if it were an exponent. 5 to what power is 25? Whatever that exponent is, that's what the logarithm equals. What exponent would go right here? 5 to what power? 2. 5 squared is 25. So, log base 5 of 25 is 2. Let's look at this one. Log base 2 of 8. Don't say 4. It might be tempting to. Log base 2 of 4.
No.
It's
log base 2 of 8. Oh, no,
log base 2 of 8. Yeah, I said.
Okay, that's okay.
Don't say 4. 4 is not the answer. Here's what I'm thinking. What I'm writing over here is my thoughts. What exponent do I put on this number called the base in order to get this number 8? How many 2's do you need to multiply together to get 8?
Not 4.
Don't say 4.
3.
2 times 2 is 4 times one more 2 would give us an 8. So log base 2 of 8 is 3. That's what I was about to write. Now, this one's tricky. It's going to remember something. It's going to require that you remember something from.
It's the first thing you wrote down the last time.
Was I doing writing over you?
Okay, 0. The definition is 0 exponent.
What exponent do you put on 7 in order to get 1? Well, a 0.
Okay. A logarithm is just a fancy way of expressing an exponent.
Now, there's two special logarithms that you'll see popping up, and if I don't mention them right off, then they'll wind up being on the first two problems. So let me just write what they are. Two special logarithms. The first one is called the common logarithm. And it's usually on your calculator. Most calculators have this logarithm. It's just log without a base. If you see log without a base, you assume that base is 10.
Here it is. On this TI-83 up here, there's the LOG key. Okay, they capitalize all three letters, LOG. You don't see a little subscript, so you assume there's no subscript, so you assume that log is base 10.
For instance, here, let's do one. If you saw log 100, do that one the same way we did these first three. If you're asked to find log 100, you'll see there's not a base down here. You've got to assume it's base 10. And so, what exponent do you put on 10 to get 100? 10, here's what I'm thinking. 10 to what power is 100?
2. I agree. So 10
You might notice
squared is 100.
when we're doing them up in our head, we keep the answer small because
So if you're punching that into your calculator, the common log, you punch in the 100. If your calculator opened a parenthesis, you need to go ahead and close it before you hit enter. And sure enough, it gives you 2.
now here's the second special logarithm. It's called the natural logarithm. It's denoted ln on this calculator up here. It's right underneath log.
Right.
I'm going to write it cursive ln. Okay. Oh yeah. It was too bright. ln is log base e. And you might think, wait, what was that e again? E was that number that we stated the last time. It's a decimal number that never repeats and never terminates. 2.718281828
But
4
y'all
5
need to remember that
dot, dot,
approximation.
dot.
That's not necessary.
Yeah. All you need to know, well,
That E is an irrational number. It's about 2.7, but I don't think there's any time they'll use that approximation, will they?
right.
Okay.
Now, when we're typing in logarithms as our answers on Pearson, never, ever, ever use capital letters. The calculator here has capital letters just so you can, tell that it's not an I, okay?
Or a 1.
The LOG and LN. But for typing in on Pearson, no capital letters. Also,
No. Oh, go ahead. No.
when you're writing lowercase ln, that L looks like a capital I. If you type a capital I, it's going to count it wrong. Never, ever, ever use a capital letter when typing in on Pearson. If you remember that, then this can't be an L, can it? If you can't have it can't be a capital I because you can't type in capital I's. Okay? So every semester I get students sending me screenshots. Oh, I got this right and it counted it wrong. And I look real close. They typed a capital I instead of a lowercase l.
And I don't change it. No, you're supposed to know logarithm begins with the letter L, not I. If you're writing out the word logarithm, the letter you write is an L, not an I. And we've told y'all, no capital letters. And if you're typing a logarithm, any logarithm, it will always begin with a lowercase l.
Exponential and logarithmic functions are inverses. That means they cancel each other out. Here are two special rules.
And we know they're inverses because the x's and the y's in their definitions just reversed. That's the classic definition of an inverse function.
Log base b of b to the x. Log base b of b to the x. This one is so obvious students have trouble with it. Log base b. Let's go back to that original definition. You're thinking to yourself, what exponent do you put on this small number? I say small because it's written small, that little subscript, in order to get the large number, the number that's not a subscript. Here, again, it's very obvious, but it's so obvious sometimes it's hard. What exponent do I put on this little b that I'm pointing at in order to get b to the x?
B to what power gives b to the x? It should be obvious.
b to the
x
x.
power. Remember, we said
B to the
inverse
x.
functions, when they're performed consecutively, they cancel each other out, leaving you with whatever domain value you had to start off with. That's what's happening here. The log base b, the exponential to the base b, they're performed consecutively, so they cancel out, leaving you, in this case, just whatever the x value is, that exponent is.
If you have the same number here and here, all of that cancels out. Now, there's another way to write that.
Remember, with inverse functions, in either order, they should cancel each other out. That means if the exponential function is written first, and then the logarithmic function,
If you have but b raised to the log base b of x. Is that green not showing
you better
good?
start using this one. September was the 10th birthday, or I guess anniversary of this pen. It's 10 years old.
I'm thinking 11.
2000? Oh, that was 24. 11 years old. Don't be using this old pen. We got to save it.
You've got a sentimental attachment to a green pen. That is pitiful, Tim.
And he's right about that. Do y'all form sentimental attachments to inanimate objects? I do. I'll admit that.
Okay, so if these two numbers are the same, all of that cancels each other out, just leaving you an x. Those two rules are going to be important, and we're going to use them for the first 4 problems in the assignment. So let's look at the first 4 problems. Well, let's start with problem number 1. Oh gosh, I hope we have it all. It says...
Uh-oh, it's sort of slow.
It's slow.
Oh.
Gosh. Wow. Hey, it's
No,
still spinning. Okay, then.
It says we're connected. It's not the Wi-Fi. We're connected by the wires, so... Okay. I think this is a bad thing. It's not even spinning anymore. Okay, let's try it again. I'll click it again.
I talked too long.
Okay, let me try.
Refresh up here. Yeah. Does this happen to y'all? Yeah.
Okay, it's trying.
Oh. Gosh, I don't want to have to...
Okay, those of you using your own devices, are your problems loading? Yes and no?
Yes, and
It eventually loads.
loaded.
Okay.
Well, we got...
Yours isn't. Uh-oh. You had to restart yours? Oh, I don't want to have to restart this.
Maybe we'll just have a whole lot of videos over this.
See, mine's no. Oh, maybe it is coming up.
Well,
Oh, okay. We're just going to wait. Oh, goodness.
Okay. Problem number 1. Solve the logarithmic equation.
This is problem number 1. Why do we have one like
X
this?
equals log base 4
That's the first problem. Wow.
of 1 over 256. The instructions say solve the logarithmic equation. When it says solve an equation, that means you should have your answer in the form x equals a number. Okay? We have the x by itself already. But we don't want this log base 4. We just want a number over here. Maybe it might be negative, it might be a fraction, but just x equals some number. So what we're going to, my thought process, I think to myself, I've got to get rid of this logarithm here. How can I do that? Well, if I'm going to cancel out that logarithm, then the small base needs to be the same number, or I need the big base here to be the same number as the small base. So my thoughts are, I'm trying to cancel out the logarithm, so I just have a number there. So x equals log base 4. Let's start with that 256. In order for these logarithms to cancel out, we've got to have the same small base and big base. So it's that common base stuff that we were doing the last time. I'm going to try to write it without the 1 over.
If you're getting rid of the 1 over, what are you going to have to stick there as an exponent? It's part of the exponent.
Negative.
Okay, you're getting rid of that 1 over, so the power you're looking for is going to be negative. So you pick up a negative sign, and then you need to know 4 to what power gives you 256.
How many 4s do you multiply together to get 256?
We know 4 squared is 16. What's 4 cubed? 64. We're getting bigger. What about 4 to the 4th? That's 16 times 16. Yeah, there's the 256.
So I'm rewriting, doing that common base stuff. I want to rewrite this fraction with a base of 4. Now 4 to the 4th is 256. To get rid of the 1 over, you make the exponent negative. Now by doing that, what's about to happen?
The logarithmic and exponential are performed consecutively.
Same small number, same big number, all of that cancels, leaving us with just the negative 4. So x equals negative 4.
So wait, we come over here and I'll type in negative 4.
Oh, it's a slow day. I'd be really worried if we weren't going to spread this out over 2 days. But even now, I'm getting a little concerned.
Okay, the next one.
Another solve an equation.
You need the base of the logarithm and the base of the exponent to be the same. And then they can be canceled out. So that should be your general goal as you're working through these.
Oh, this is bad. So what do you think? If I restart it, will it go faster? Yours is not.
Yours is
no.
not? No.
Well,
What about Amazon Web Services? Have they messed up again? Remember that?
It's slow over here.
Oh,
Every Monday and Tuesday, or every Monday and Wednesday from here, it's always slow.
not for us.
Monday it was good.
It was
Today's not good.
Oh, here's a
okay,
good
here's a good one. X equals log base 3 of the cube root.
Realize that's a cube root of 9, not a square root of 9. Be careful there.
It says solve the equation. If you're trying to solve an equation, your ultimate goal is to get x equals some number. So we don't want this log base 3 there. We just want a number. The way we can cancel out this log base 3 is by having a big 3 right
3
after
to
it.
power.
Let's see. X equals log base 3. I'm going to start with the 9. 3 to what power would give us a 9? 3 squared? Now, wait, what about this cube root? Here's something that goes back to the last time. I should have bookmarked that page. Oh, do you remember when we were looking at fractional exponents, we said the top number is the power, the bottom number is the root. Okay? Top number is the power. Well, that's the 3 squared. What's the bottom number going to be? What's the root?
That red 3.
Do you see how I rewrote cube root of 9? First as 3 squared, and then over 3. So the 3 squared is the 9. The bottom number here is that root. Top number power, bottom number root. Can I cancel now? Yeah, we have the same small base and large base. All of that cancels out, leaving us just the 2/3. When you're solving an equation, you want x equals a number. It might be a fraction, it might be negative, but you didn't want this log base 3 there. That's what gives me the idea, oh, we got to cancel that.
You say to yourself, well, suppose this had been a 7 down here. You can't write 9 as the power of 7. Well, in that event, this method doesn't work. So the problems have to be in a format where you can get that common base.
But that common base is, the realistic applications, there is a common base.
And that's not really a bad restriction, the fact that you have to be able to get the same base here as the base of that logarithm.
From now on, you want to talk. Move to the next question and then start talking while it's trying to load. Going back over here so that students can look at that and you can now talk.
Oh, I have nothing to say.
Oh. Well, either way, let's put it, while it's doing that, just put back so they can see this and I'll talk.
Okay. But as we were saying, that restriction isn't really bad, okay? It does realistically happen. If that base there is a 4, this number you're working with will be able to be written as a power of 4. Well, I suppose this is a power of 4 and that's 5. That just doesn't happen, okay?
No, I mean, you could write it like that, but it doesn't really happen that often. With logarithms, you usually have a common base.
Oh, I like this one too.
Look at number 3. X equals
10
to
the
10,
log 7.
and then the exponent is log 7. Oh, wait, did they have parentheses?
Yes.
I don't think they really needed those parentheses around the 7, but we want just x equals a number. We don't want that logarithm. That gives you the hint. We better be able to cancel out that log.
What's the subscript on this log? If you see log and there's no subscript, you have to assume that the subscript is, it has
10.
to be a 10. And right here. Look right there. That does it.
Oh, yeah, but I just wanted to point out. Remember, I said log is called the common logarithm, and it's a log base 10. So even though it wasn't written there, we assume it's a 10. And now, is this going to be hard or not so hard to cancel now? Not so hard. We have a 10 and a 10.
Cancel out.
Cancel it out. You have your black X on the left. And all that's on the right is that red 7. So X equals 7.
Exponential and logarithmic functions to the base b are inverses. When performed consecutively in either order, they cancel each other out.
Or in other words, same big number and same small number, they cancel out. Same big number, same small number.
And they're consecutive. You couldn't have something between this big number and that log notation, likewise here. The log notation and then the base. They've got to be consecutive. But if they are, then they cancel out. Oh, it's not up yet.
Oh, well, you can keep on talking. Go back over and put there. Notice on these first three that x has already been by itself. So you didn't really have to isolate the x. You just had to get a number on the right-hand side. On problem number 4, you know what? I think I'm going to do number 4 right here. Log
Base 5 of x.
Base 5 of x equals 2. My number 4 is right there.
I see.
How does this differ physically from the first 3? Well, the first 3, the x was by itself. Here, the x is not by itself. But our goal is still to get x equals a number. So somehow or another, I need to get the x by itself. In order to get the x by itself, I need to get rid of this log base 5. So, thinking about this rule right here, if we have a small 5, what big number would I need right here to cancel out? What big number do I need to put here that would cancel out log base 5? 5. Whatever you do to one side, you've got to do to the other. It's going to look a little strange.
This is reminding me of that same base method that we were using the last time to solve exponential equations. Remember, with the same base method, we'd get the same base on both sides, then we drop the base and set the exponents equal. Now we're doing it in reverse. The exponents are equal, so we add on the common base.
And do you see now the big 5 and the log base 5, all of that cancels? That leaves the x by itself.
And now over here,
let me write it a little neater. This green 5 is a base. The black 2 is an exponent. Don't say 10.
That's saying 5 squared. What's that going to reduce to? 25. Why can we stick that 5 on there? Because the same way we were able to get the same base on both sides and drop the exponents, and drop the base the last time, we're just going in reverse. These are exponents, so introduce the common base. And that's why we said it wasn't a hardship that the logarithm base and the base that you're using there have to be the same, because in most cases you're going to be choosing the number. What number do you put here that would cancel out a log 5?
Why would you put a 4 there? A 4 would have canceled. You choose the number. Hey, do we have time to try to put in the answer for number 4?
25. We have time for what?
I wonder if we have time to... You know what? I'm just going to make another 4. Let's pretend I've regenerated this one. Here's...
Scoot down.
Okay. This is an example like number 4. Y'all can tell me what big number... Well, first you'll have to tell me, do we need to put a big number? And log base 3 of x equals 81. Here's my thoughts. I want just x equals a number. Oh, wait.
I think it was supposed to be a 4.
It was. I missed. Oh, gosh. My great example, I blew it. 4. Okay?
That was supposed to be a 4 there.
You can probably guess what the answer is going to be based on my mistake. Okay.
Well, maybe they didn't. So.
Okay. Well, the x is not by itself, so I need to cancel out this log base 3. What big number do I need to put on both sides that'll cancel out log base 3? A 3. cancels it. We just have an x. And on the
this
right,
looks funny, but it's saying 3 to what power? The 4 power.
which is not 12. Y'all want to guess what it is? 81. If you multiply 4 3s, you get an 81. It's like 9 times 9.
So
whatever if the x isn't by itself, whatever that base is, that's what you put on each side.
and you can do that because for the same reason that we were solving those exponential equations, once you get the common base, you drop the base, set the exponents equal. Here the exponents are equal, so we introduce the common base.
Now, one more of these, and hopefully once I'm through with this one, we'll be ready to move on. Oh, actually, I'm going to have to talk some more before we can do number 5.
Okay, that's fine.
Log x equals 3. What's missing here? That little subscript, that base. What base is it?
If you see log without a subscript, you assume it's a 10.
Now, what base am I going to put on both sides to cancel out the logarithm? 10. And that leaves me just x equals, it's a 10 to the 3rd power. 10 times 10 times 10 is 1,000. That's right. By the way, that Duolingo app that I'm using to study languages, they have math as one of the topics. And I remember at a time when I was struggling, someone would always get the top spot in the little league I was competing in. And then they began the math. When they started the math, I was like, oh, wow, this can't be true. I mean, this got to be a joke. So I was able to get first place in every league I competed in then. But now I've lost the interest in whether I'm first place or you can be first place by doing something that's real easy. And I don't feel any satisfaction from it.
Oh, some of that math is actually pretty good.
Some of it's good.
It's really good, yes.
Okay, now we have some rules of logarithms that are so important, they're going to have names. We're going to look at something called the product rule of logarithm. Then we're going to look at the quotient rule and the power rule. The product rule. You want to do it?
I can.
Oh, okay. Here. You have your microphone?
Oh, yeah. Okay.
Tim.
Oh, no. Oh, oops.
Okay.
Okay. I'll take over. You've been talking for 40 minutes. So I'll talk now. Okay. The product rule of logarithms. The product rule of logarithms The product rule of logarithms says log base b of the product m like money times n Nancy. If you have a product inside this expression here, it can be rewritten as the log base b of m plus the log base b of n. That subscript we said is the base. I don't think you mentioned what this thing is called here, Tony. This thing that follows the log notation is called the argument. So if your argument has multiplication in it, you can split it up as the sum of the individual logarithms. Remember I said that logarithm is just a fancy way of expressing an exponent. There's a product rule of exponents. I don't remember if we've used it or not, but I want to remind you of the product rule of exponents.
Every time you go x times x is x squared, we use it. So what do you mean?
B to the m times b to the n. Here's the product rule of exponents. If you have the same basis being multiplied, to write it as a single power of b, you add the exponents, m plus n. Remember we said that logarithms are a fancy way of expressing exponents, and so there's a strange similarity between exponent properties and logarithm properties. Here, you have a product in the argument, you add the individual logarithms. Here, you have a product with the bases, you add the individual exponents. So there's a strange similarity, and it's to be expected because logarithms are just fancy exponents. I think I should state the three and then look at examples with them. What do you think? The quotient rule. The quotient rule of logarithms.
If with multiplication you add, most students can figure out the quotient rule real easy. Quotient means division. So what would you guess it's going to be? If multiplication, you add, what do y'all think division's going to be?
Arguments being multiplied, so you add. Arguments being divided, what do you think we're going to do? Subtract. Log base b of m minus log base b of n. And I want to remind y'all of the quotient rule of exponents. The quotient rule of exponents is our cancellation property, basically. The quotient rule of exponents says b to the m divided by b to the n. If you want to write that as a single power of b, you have the same basis being divided. You subtract the powers m minus n. You're canceling the common factors. And how many powers do you have left? Well, m minus n. For example, b to the fifth divided by b cubed. Cancel 3 b's above and below. How many b's do you have left? 2. 5 minus 3, which is 2. So once again, this property of logarithms, the quotient rule, has a strange similarity to the quotient rule of exponents. The arguments being divided, you subtract the logarithms. The bases being divided, you subtract the exponents.
And this is just a little...
Oh, and that's just a little smudge there. That's a little smudge. That's not a decimal point. One more property with a nice name. The power rule of logarithms. What color should I use? I'll use this one here. The power rule. This is the most bizarre. People consider it the most bizarre, but it's actually a very nice restatement of the power rule of exponents.
The power rule of logarithms. It's better than power rule of logarithms.
The power rule of logarithms says if you have log base b of some argument m raised to the n power. You know, before I state this, I think it's a good idea to remind y'all of the power rule of exponents. And I know we used the power rule of exponents the last time. Let's see. We had, is this, okay, b to the m raised to the n power. Do you remember what we were doing there? When you have a power raised to a power and you want to write it as a single power, what do you do to the exponents? You multiply m times n. A power raised to a power, an exponent raised to a power. An exponent raised to a power, you multiply. I said a logarithm is a fancy way of expressing what? An exponent. So an exponent to a power, you multiply. You multiply n times log base b of n.
So it looks like you move the exponent down in front of the letter L.
And the reason we're able to do that is because a power raised to a power, you multiply. A logarithm's a power raised to a power, so you multiply. And you put the n in front so that you're not multiplying the argument by the n, rather the entire logarithmic expression. And that is very significant, the fact that we can pick up exponents and move it down in front and write it as a coefficient.
Exponent at the end.
An exponent that's on the entire argument. It has to be an exponent that's applied to the entire thing right there, that entire argument. You'll see what I mean as we move through this. And I think we're ready to start expanding.
I'm going to say cancel. Okay. Oh, good. Well, we're not doing that one. Let's go ahead.
I'm going to make up an example. What I want to do is we're going to take single logarithms and write them as sums and differences as of multiple logarithms. Now the single logarithm, showing that problem that we were just looking at, look at that argument. There's the log base 2, but look at everything that's in that argument. It would be better if they had that big fraction in parentheses. What we're going to do is try to write it as multiple logarithms with simpler arguments.
Here the argument is just x, y, w, z.
We're trying to get it so that we're going to rewrite it so that each argument is just a single factor. Now, rather than going through and showing every step, what we need to do is get to a point where we can combine the product rule, quotient rule, and power rule into as few steps as possible. In order to do that, we got to make some. We have to make some observations, and so here goes.
The formal name of what he's about to do today is expanding logarithms.
Expanding logarithms.
And it's a 4-step process if you're going to show every step. This is one of those rare times when you're better at it not showing every step. Except for the first time you're doing it, you need to see every step. And there's an order to it. When you're expanding logarithms, the first thing you do is use the quotient rule.
Well, I'm just going to define what we mean by expanding logarithms. We're going to rewrite a single logarithm as the sum and or difference of multiple logarithms.
And even though we stated them, product, quotient, power, usually you don't start with the product rule. The first thing
if your argument contains a fraction, the first thing you're going to do is the quotient rule.
Write out the 4 steps. 1, quotient rule.
I'll say general procedure. First thing we'll do is apply the quotient rule.
Then we apply the product rule. Now don't write the 3rd step. Let's see if they can figure it out what you're actually doing in an example. 3rd step, leave blank. 4th step, power rule. Usually, y'all can figure out that 3rd step.
I like that. Let's see if they can figure it out. But I'm worried. Do you think I'll be able to get it all? Well, I guess I can. I'll write small.
Write small if you can. So. Okay.
Maybe you better do this because you know I can't. No matter what, I'm going to start writing big when you're a multiple penmanship award winner. I just want to show
finally
off that
figured
writing.
out last night or yesterday that the reason the teachers gave him that penmanship award all those years was because they tied his left hand behind his back.
They did not tie my left hand behind
Well,
my back. They tied it down.
Okay,
on
whatever.
the desk.
But I think that was their, we really shouldn't be tying hands down. We'll give him an award for his writing. All right.
I never thought of that, but maybe if there'd been a fire, the building had caught on fire. I mean, I was small. How would I have gotten out? I couldn't get I guess I would have had to drag the disc out with me as we
Why
walked.
did they do that?
Huh?
Why did they do that?
Because you
forced me
didn't
to
want to
write
be
with my right
weird.
Oh,
And
you let
back
me-
in
a
the
little
60s.
town in East Texas in 1970, they weren't going to let me be one of those odd, weird, left-handed people. Yeah, that was
a common practice back in the olden days.
Back in the olden days.
I think they thought it was a sign of witchcraft.
I don't know, but you're right. It was. Has anyone ever heard of that happening? Back in the 70s, that was very common.
I never heard of like people like tying your hands down. We had Armenians, they would smack their hand with a ruler.
Oh, no.
Well, I think that might be why.
Yeah. I just didn't understand why they tied it down.
They tied it down so I'd resist the urge to use my left hand. Now I don't use my left hand for anything. Although the doctor says if I lost my right arm, that my left hand, I would pick the ability back up.
Okay, enough of that anyway. Okay, look at this messy logarithm. Our goal is to write it as sums and differences of a lot of small logarithms. The first thing we're going to do is that quotient rule, which said if you have a fraction, it's log top minus log bottom. So I'm going to write QR for quotient rule. Log base 5 of the top stuff, x squared y to the 1/3,
Is your microphone
minus, I thought it was,
Okay.
is it on?
on? It's on, yeah.
Okay.
It was just-
Minus log base 5 of w to the 4th, a to the 5th. Oh. So that's what the quotient rule says. If you have a fraction, it's top minus bottom. Now we're going to use the product rule, and I like to put the little dots to show where the multiplication is. It's right here, and right here, where would I put the dot to indicate multiplication?
Okay.
Right there? So we're actually going to use the product rule twice. So this is the product rule. So with this one right here, it's log base 5 of x squared plus log base 5 of y to the 1/3. I'll carry down this minus. And we'll do the same thing for this logarithm, except all of this stuff is going to be multiplied. So it's log base 5 of w to the 4th plus log base 5 of a to the 5th. So I'm using the product rule twice on the first logarithm and the second logarithm. And by putting these parentheses here, I sort of gave a hint to what this third step is that I didn't list. Since there's parentheses here and a minus in front, what am I going to have to do with that minus? Distribute it. That's the third step. Distribute the minus. So let me write it all. I'm just going to write it in one color. Log base 5 of x squared plus log base 5 of y to the 1/3, then a minus log base 5 of w to the 4th. And if you're following along, what am I about to write? A minus log base 5 of a to the 5th. So that was distribute the minus. Now the power rule. You're probably thinking it's hard to believe in a minute you're going to be able to do this stuff in your head. The power rule says the exponent that's on the argument at the end, you can move down in front. So like right here, I don't have the parentheses around the x, but that's fine as long as it's the exponent's on the argument at the end. So it's going to be 2 log base 5 of x. Then move on to the next one. Take the exponent, put it in front of the letter L. 1/3 log base 5 of y. Carry down. This minus is right here. Put the exponent in front of the letter L. Exponent in front of the letter L. Now, there's your answer. Okay. Let's look now and see if we can figure out a pattern to go from here to here. I remember 15 years ago, I was going through all this. If you look at view and example, they show these steps, every one of them. And I remember when my brother, I was like, darn, that's long stuff, those logarithms. And my brother was like, this has been taught in separate classes. He said, well, you were the one that told me, don't show the steps.
Since 1990,
and I was
started
like,
having to teach this stuff in 1324.
Look, they don't. He said, just write out the final answer when expanding logarithms. I was like, oh no, those students, they want to see the steps. And he said, no, they don't. And I said, well, I'll give it a try. And oh wow.
But you realize I've been doing that for 15 years that way.
There was a lack of communication. Here's how you go from here to here.
Okay, first of all, how many total factors do we have in the argument? The way he put those multiplications. How many different distinct factors do we have on top? Don't say, well, you have 2 x's. Just how many factors? Distinct factors. 2, x and y. How many factors do you have on the bottom? 2. That's a total of 4 factors. So we're going to need 4 logarithms. 1, 2, 3, 4. 4 logarithms are our final answer.
Let's look at the plus and minus signs. In particular, the minus. In your final answer, the stuff that's on the bottom has what sign in front of it? Plus or minus? Minus. Okay, so if it's on the bottom, it should have a minus in front of it. The exponent should go in front of the letter L. I'm going to do one without showing any work, and I'm going to make it really messy.
Okay, but if the factor's on top, well, I don't see a sign in front of that 2. If you don't see a sign, you assume it's what? Positive or negative? Positive. Any factor that's on top has to have a positive coefficient preceding it. A plus sign, positive.
And the stuff on the bottom,
minus. What determines the coefficients? Where did those coefficients come from? From the exponents. That's right.
What we're doing is we're going from one logarithm, in this case to 4. And you separate logarithms at multiplication and division. Notice, well, I guess you don't need to. you'll see as we go on, you don't separate them at addition or subtraction. Remember years ago a student saying, you seem to think those red dots are important. Now I said, yes, that's where you separate them. Now
But realize log base b of m plus or minus n cannot be separated.
we'll state
the
that
argument.
formally
Okay.
in a moment. Here's
Maybe we won't get to that today at the rate we're going.
expand. Let's expand this logarithm. Log.
Fine with that.
Let's.
Radical.
I'm going to do it.
Make it a common log so you don't have to write that
Yeah.
10.
I'm going to write just log base 10. I'm using common log so I don't have to be writing the subscript. So suppose we had this. Log. Actually, let's just do the square root in the next, in problem 5.
Oh, okay.
Here, just to get the pattern. Log a to the 5th b cubed c all over 7x squared.
That's enough.
That's enough? Okay. I want to expand this logarithm into how many logarithms? How many logs are we going to have? Well, you separate at multiplication and division. So I'm putting little red dots everywhere there's multiplication.
So how many distinct factors do you have on top? 3. Okay. A, B, C. There are 3 distinct
And are
factors.
those going to be positive or negative factors? Positive, because they're on the front top. On the bottom, we
Be careful.
have...
Okay, put the dot. How many factors? 2. 7 times x. You can split up that 7 into x squared.
And now I'm even going to make my little fraction bar.
So how many
for
total
here.
logarithms are we going to have? 5.
Okay. I'm going to go ahead and get started with the a to the 5th. The exponent goes in front of the letter L. So 5 log a. Now I'm moving over to the b. Am I going to write plus or minus? Plus.
Because the b is up on top, so it's a plus.
3 log b.
Plus or minus? Plus,
Plus.
because the c is on top. Are we going to have a coefficient on this logarithm? No, other than the assumed
exponent.
1.
No exponent, so just write log c. Oh, I should have been writing smaller.
You're writing so neatly that...
Right. Now we've gone to the bottom. Since we're now in the denominator, I'm going to put a minus. There's not an exponent on the 7, so we just write log 7.
Now to be clear, if you wanted that 7 to be squared, they would have had to enclose the 7x in parentheses, and they didn't. Only exponent is, oh well, and Tony didn't. The only thing being squared is the x, not the 7. That's a common mistake. People will put that 2 in front of the log 7 and they'll be counted wrong. Plus or minus for the next one.
Minus.
Once you move down to the bottom of the fraction, the signs have to stay minus. Because remember the way he distributed that minus.
Yeah, that is it. They're distributing that minus. Sometimes students say, well, wait, it's multiplication, why don't you put plus? Well, we did when we were going through the steps.
But then you distribute the minus. Once you start using minuses as the connecting operation, you cannot switch back to plus. Because that minus from that big fraction bar, that minus is going to be distributed over every remaining logarithm.
Now for the x squared, what are we going to write? 2 log x. When the problem number 5 is multiple choice, but for the ones that aren't multiple choice, it's going to take longer to type in the answer than to actually get the answer. Okay? Now, if you look at view and example, they're going to go through every step every time. Okay? the quotient rule, product rule, distribute the minus, power rule. It's best if you don't do that. Think separate it, multiplication and division. And I bet that problem number 5, have they timed us out?
Probably. Oh, there it is. I told y'all you have to add something to your bag of tricks when working with logarithms, something involving radicals. What's that trick you're going to have to pull out of your bag of tricks? Not negative exponent, but starts with an F.
Not FOIL,
Not
or
FOIL,
factor,
not
or...
factor. How did we rewrite radicals using exponents? What exponent is the same thing as a square root? A fractional exponent. That's the thing. When you see a logarithm containing radicals, you must rewrite them using fractional exponents, and that's going to be an added step to this problem. We're going to have to rewrite those radicals using exponents.
Okay, well,
let's make sure you didn't miscopy. Square root of x, cube root of 1. Okay.
Click on one of those.
Oh, I want you to see something. Look closely here. You see that little 3? It's right there on the hook. That's saying the cube root of y. That 3 is not saying you're cubing the square root. That 3 is the index. That's saying the cube root of y. Notice how the 3 is right over that little hook.
Is that a 5th root on the bottom?
Is this a 5th root of z? Is that 5 right over the hook? No. So that's w to the 5th. What sort of a radical is this? A square root. Okay. It's important you tell where the that 3 is an index. This 5 is just an exponent. Look how Tony wrote it.
We've got
Notice he's clearly showing that the 3 is an index on that radical, but the 5 is a power on w. So there's an added step here.
If you have a square root?
A square root is the same as what sort of a exponent? 1/2. What about the cube root?
Oh, let me dimension. See, square roots are 1/2 exponent. Cube roots 1/3 exponents.
And the way he's showing, go back, show him the little arrow. He's trying to say you'll be using those in reverse. You'll have a radical, you have to rewrite it using an exponent. Okay?
So this would be 1/3. What exponent am I going to write on the z? 1/2. Now, it's just like the example we finished doing.
It's shorter, as a matter of fact. How many distinct factors do we have on top? 2. What about on bottom? So how many logarithms do we need? We're going to need 4 logarithms.
How many minus signs are we going to have? 2. I'm just going to start writing it out. We start with the 1/2 log base 2 of x.
Plus or minus? Because you're up on top of the fraction, so plus.
1/3 log base 2 of y.
Plus or minus? Minus, because we're moving down to the denominator. And once you move down, you don't go back up. That's why you have to keep those minuses preceding the log notation. Plus or minus? Still a minus, because you're still down there in the bottom. For this first expansion, it's nice because they're giving it to us as multiple choice. But you will have to be typing this stuff in for starting probably in the next problem. And typing those subscripts, you're going to develop all sorts of appreciation for LOG, for common logs and natural logs, not having to mess with those subscripts. Okay, let's see. A, B, C, oh no! Yes. A, B, C, or D. It's not D. A, B, or C. D, the 1/2.
What's C? You said D.
It is C.
Oh, yeah. But I thought you said D. I misunderstood you.
Oh,
it is
then
C.
It's C. What did I say? There.
It doesn't matter.
Okay.
It's C.
It doesn't matter. You're
Now
right.
let's discuss this cannot be simplified. You separate logarithms at multiplication and division. Do not separate at addition or subtraction. Is my screen showing?
Yes.
When it says cannot, that option D there, what did it say? Cannot be simplified. Suppose we had this. Log base 2, 3x minus 4 plus y. What do y'all think the tempting wrong thing to do is? Maybe to try to distribute that log2? You don't distribute. Can you separate this at all? When we break it up into 3 logarithms, where do I put the red dot? Well,
Right there, but that has a minus 4 attached to it.
you can't separate at addition or subtraction. This thing cannot be separated, simplified. What do they say? Simplified? Okay.
If your argument contains addition or subtraction in the original problem, you have to have that same addition and subtraction in the simplification. So I guess you could say log base 2 of 3x minus 4 plus y is equal to log base 2 of 3x minus 4 plus y. All you can do is recopy it.
Let's look at number 6.
I should have been trying to.
Oh, look how fast it is. Log base b, and that's a b, right? Not a
B.
6. Okay. Of x squared y all over z to the 5th. I just did that one to write small. It's your turn to write.
Oh, yeah.
Okay. Okay. Show us that penmanship. Okay. Can it be simplified, or is it like the example I did right above it, but said can't be simplified?
It can be simplified. Now,
Put your red dots and fraction bar.
do I need to rewrite using rational exponents the way I did on number 5? No, because there's no radicals. We have x squared times y, and I think that's the only product. So with that in mind,
I'd draw the fraction bar in red.
oh, draw the fraction bar in red, yeah. So you can
Use the
separate
code.
at multiplication and division.
Years ago, that student telling me, you seem to think that those red dots are important. Why are you putting them there? Okay, and hopefully you can answer that. Yes, they're important. That's where you separate them.
Okay, how many logarithms am I going to need in the expansion? 3. I do something different from my brother. I write that log notation. Log base b, skip some space. Log base b, skip some space. Log base b. The first logarithm. Will I have a coefficient in front of it? If so, what will it be? The 2. Okay. Argument. What did he say? The x, plus or minus? Plus, because we're still up on top. Do I have a coefficient on the second logarithm? No, because y doesn't have an exponent on it. The argument is y. Plus or minus? Minus, because we're going down to the bottom. Is this like, are we going to have an exponent, a coefficient here? Yes, it has that power of 5. That becomes the coefficient. Argument Z.
This is the first time we type in a logarithm.
I know.
Am I going to use capital letters? No.
Okay.
You type it in. If you're typing this stuff in correctly, notice, y'all see how the log is bolded? If you're typing it correct, it'll bold it.
Once you type that G,
2 L-O-G.
and
Now,
notice it bolded.
look at this. And it also spaced it. See, if you're typing it correctly, it spaces it correctly and bolds the LOG. All the time I get students emailing me asking, how do I bold the stuff?
You don't bold it. It bolds automatically when you've entered it correctly.
Look at this.
Look at G. Hey, it says too long the way it's supposed to, but it didn't bold. What's wrong?
I typed a capital I instead of the L, okay? So
It looks like it's long. It says long, but that's an IOG.
log. Now I type the subscript.
Do y'all see, I think this is the first time we've typed subscripts. Do y'all see the little subscript button there?
Make sure
Hot
you
button.
don't put the X down there in the subscript. Right arrow X plus L-O-G. Notice I'm not hitting space or anything. It's spacing it the way it should be. And then minus 5 L-O-G-Z. This is one of those problems.
No.
Oh, wait. Oh, what'd I do wrong?
You did it 2 times.
I did it wrong twice. What'd I do wrong? Look at that. I gotta do my subscript.
You don't put the subscript. If it's showing a subscript and you don't type the subscript, it'll count it wrong.
It's just, merciless.
Oh. If they have a subscript and you don't type the subscript, then you have incorrectly changed the logarithm to log base 10, to a common log. If it shows a subscript, you must type that subscript.
Okay. Tim, keep going.
Oh, number 7.
Shoot.
Just
Let me see.
What is going on?
There's, when you're doing these problems now, there's going to be little notes. And it's just not doing it. Okay, I wonder if it's going to let me type this answer in. The note says, never type capital letters. Don't hit space. Logarithm begins with the letter L, E-L, not a capital I, E-Y-E. It's so stupid. You'll see it. Yours has that little statement. Okay.
Does it have it? Okay.
The fact it keeps making me want to sign in, I suspect I'm about to lose it.
Okay.
Okay,
Well,
so try
let's
this
do
one
this
real
one.
quickly, Tim.
Okay.
There's one thing he needs to do before he begins the red dots.
What do I need to do? I'm looking at that argument. There's something there that I need to change. Change the square root to, okay, log base D. So that's an x to the 1/2, y to the 6th, all over z to the 9th. That's, how many distinct factors do we have on top? 2, x to the 1/2 times y to the 6th. So we're going to need 2 logarithms right there, divided by, how many distinct factors do we have on bottom? 1. So that's going to be a total of how many logarithms? 3. Okay, so I'll write them out. Is that a log base D? Log base D and a log base D. I'll move left to right. Do I have a coefficient here? If so, what is it? 1/2 argument x plus or minus plus, because we're still up on top as we move to this next factor. Do I have a coefficient here? What is it? 6 argument
plus or minus? Minus, because we're moving down to the bottom. So a minus, are we going to have a coefficient here? Yes, what is it? 9, argument z.
Let's see if it lets me type this in, or am I going to have to log back in? Okay, so 1/2.
Get out of that denominator before you type your log. Oh, if you use the little key shortcut, remember for an exponent, it's shift up arrow. For a subscript,
No one does.
it's shift down arrow. Does anyone use this key shortcut?
That was back in the olden days, Tim. You've got to move into the new generation. No one uses that. Oops, what did I do wrong?
What did he do wrong?
I put a Y there, and it should have been a lowercase d. There.
And then the y.
Y. Hey, look at this. If I go minus 9, let's suppose I want to type capital L-O-G. Did it bold it? No, don't do that.
Never
Lowercase.
type a capital letter or a space in my lab.
T Z. Take it.
Yeah. Okay. Number 9. No. Oh, that was.
No.
What did we just?
Wait a minute. For some reason it.
6.
Oh, did we do the?
I think you skipped one.
Did I?
Is
Oh
that-
my goodness. Okay, so
Okay.
that's. I'm
Yeah, let's
sorry.
go back
How
to
did
number. That was
happen?
number 8 that we just did. Here's number 7. Oh, log the 8th root
That's
of
eighth root.
x over z.
No, is that 8th root over both the top and the bottom, or is it just on the x?
It's on the top and the bottom. So you're going to write it as x to the 1/8 over z to the 1/8.
I was going to ask him what fractional exponent
Oh,
would be the one.
yeah. And 1/8, I mean, an 8th root is the same thing as a 1/8 exponent. So, any questions on what I did there? How I was able, that the x was under the 8th root, the z is under the 8th
Tim,
root.
over there-
I need to make it look more.
Write it where if the radical is only on top, just
Oh.
over here.
Okay, let's suppose we had an 8th root of
If it looked like
x
that,
all over z, then you would have the x to the 1/8, but the z would just be a z.
okay,
Yeah,
is it
that's
clear
mighty
this is
messy,
on both
but
of them?
in fact,
Write
here,
out the answer, Tim.
I'll let him call it out to me. How many logarithms am I going to need? 2. I only have one factor on top, one on the bottom. So I'll write my log and my log. Do I have a coefficient here? If so, what is it? 1/8 argument x plus or minus. Minus because we're moving down to the denominator. Do I have a coefficient here? If so, what is it? Another 1/8 argument z.
So 1/8 log x minus 1/8 log z. Okay. Oops, wait. 1/8 log x. What's going to happen there? Is it going to give it right or wrong?
Wrong.
Okay.
The logarithm is not in the denominator.
Log x.
Oh, it's so nice not having to type those subscripts.
1/8.
If I take over the world, I think I'm going to, when I take over, that's going to be one of those rules I'm going to make. For illustration and classroom purposes, you can only use LOGs and LNs. That way, no one has to
Hey,
type
you haven't even had
subscripts.
an alien pop up.
Yeah,
It'll be the exact same thing.
and we've already done
Oh, it's speeding up. Okay.
it. Is.
Oh, look
this
at
is a good one. Okay. Number 9.
This is one of those things when
It's an LN. That means It's not a capital I. Look at that 4. Look at that 4.
Which 4?
On that, that's between the x and that radical. Is that a fourth root, or is that 4 an exponent on x? It's an exponent on x. What sort of a radical do we have there? That's a square root, okay. And
How we
wait, let me make sure I don't miscopy. Yeah, okay.
now we've tried to hint at it. We don't separate at addition or subtraction.
If your argument has a plus sign in the original problem, you're going to be stuck with that x squared plus 8 in your final answer. Look here, an x plus 8. You have a plus in the argument of the original problem, you're going to be stuck with an x plus 8 in your final answer. You cannot split up that x plus 8. You can't split up that x squared plus 8. One thing I do is I immediately rewrite that square root as 1/2 exponent. So you have x to the 4th, and then you have an x squared plus 8 to the 1/2 all over x plus 8 squared. There. Is that legible?
Mm-hmm.
Okay.
Let's put a red dot.
Okay.
There's only one
Time they're being multiplied. What's being multiplied? After the x to the 4th, it's times x squared plus 8.
So this is going to separate into how many logarithms?
How many distinct factors do we have on top? We have x to the 4th times x squared plus 8. That's all one factor. So there are only 2 factors on top. How many distinct factors are there on the bottom? Just one, that x plus 8. So we're going to need a total of how many logarithms? 3. Okay.
ln, not in.
I think I'm not going to write the 3 ln's all at once, okay? Because
You're going to do it my way.
yeah, I'm going to do it your way. We have the first one. Here's the ln. Do I have something in front of it? If so, what is it? The 4. And then the argument, x, plus or minus, plus because the next factor is still on top. So we have a plus. Do we have a coefficient? What is it? 1 over 2 ln. The argument, your argument x squared plus 8 must be enclosed in parentheses. Otherwise, if you type it in without the parentheses, the only thing you're taking the ln of is x squared. If your argument has a plus or a minus, you need to enclose that argument in parentheses. That x squared plus 8 was in parentheses. It's going to be in parentheses in your final answer. Plus or minus. Minus, because we're moving down to the bottom. Do I have a coefficient? 2. ln argument x plus 8. I have to put it in parentheses. You type it like that, I can assure you they're going to count it wrong. If your argument has a plus or minus, enclose it in parentheses.
So at this point, if someone says, say something about logarithms, you can say, separate logarithms at what? Multiplication
And division.
division.
You cannot separate logarithms at addition and subtraction. Oh, wait.
So I've got to type all of that in.
But at least it's an ln. You
Yes.
have to type a base.
4
ln x
4 ln x plus 1/2
right arrow
ln parentheses
x square.
Always going to need a technical typist, Tim.
Plus
minus.
Years ago, there were math departments would have technical typists. And those were the people that could type the fancy symbols on an old-fashioned typewriter. Well, minus 2. Look what I'm about to do. What's wrong?
It didn't bold. Highlight it and press bold or something.
Oh, well, you can't do
You
that.
can't do that. That's
No.
right. He typed an I
I.
instead of an L. You laugh now, but we'll get those emails.
X
Not from y'all, of course, okay? As we've told y'all, but
4 ln x plus 1/2 ln x squared plus a minus 2 ln. Okay.
and from a calculus point of view, if you had you're wondering why would you want to do that? If we needed to differentiate this logarithmic expression, say in a calculus 1 class, that sum or difference, I could find that derivative in my head. It'd be a 4 over x, the expanded form. That expanded form is much more desirable from a calculus point of view. So you say to yourself, well, you work at American Bank or something, and you're not going to need to expand logarithms. Yeah, but if you're going to take a calculus class, you're sure going to need to know how to do it. So this is stuff that's skills.
Electrical engineers going to do a
Yeah.
lot of. But anyway, in math class, in algebra in particular, you always do it one way, and then what do?
Do it the other way.
Yeah. Let's see. Could y'all state rules on how to go backwards? Let's look at this one.
Oh, sweet.
Right there.
Yeah, let's see. Let's look at this example that Tony made up here.
Could y'all?
Could you go backwards? Because that's the next thing we're going to be doing. We've expanded logarithms. The next technique we're going to learn is how to condense logarithms. They're going to give you multiple logarithms, and you're going to go back to a single logarithm. So let's see. Could y'all go from here back? We know that the coefficients become what? They would become the exponents. If I don't see a sign there, so we assume it's positive. And so the logarithms that are preceded by positive coefficients, where do their arguments go?
Top.
On top. The logarithms preceded by minuses go where? Their arguments go on the bottom. So you think we can do that and go backwards?
Let me see.
Are we already ready to start condensing?
Never
What?
type. It's that. For some reason, it won't.
Okay.
It is 3:42. You want to do this one problem?
I'll
then
do this
stop?
one and then I'm going to stop, okay?
You know what? Actually, instead of doing that one, do it with an X and a Y.
I will.
Here's an example similar. Okay, it's similar to number 10. Log.
Well, first of all, I want to define what I mean by condensed logarithms,
Oh.
okay? Many times they just say write it as a single logarithm, but if you see the phrase condensed logarithms, that means you're going to rewrite multiple logarithms as a single logarithm. Rewrite multiple logarithms as a single logarithm. So suppose you were told, I'm going to make up, condense the following logarithms.
Yeah, wait.
Okay.
Minus log base 4 of Y.
Log base 4 of x minus log base 4 of y.
Can I put it? Can I put it? Can I put a number?
Okay. I'm going to put a. Okay, I'm going to add a coefficient. I'm going to put a 3 right here. Okay. That 3 looks funny, doesn't it?
So we want to write it as just one logarithm.
That means we want to write it as one logarithm, and it's log base 4s. My first question, do I need a fraction bar in this new argument? Yes, what's saying that I need a fraction bar? Okay, this minus sign right here is what's saying you're going to need a fraction bar. What are we going to have on top? X, do we have an exponent on it? No, there's no coefficient, so it's just an X. Now, that minus says we're now moving down to the bottom. What are we going to have on the bottom? Y. Am I going to have an exponent on that Y? Yes, 3.
A common mistake, students write 3y rather than y to the third. No, no, no. The number in front of the letter L is an exponent.
What's number 10?
Okay, so here's number 10. After that, we'll stop. Your mind's got to be reeling. Log base 4 of 7 minus log base 4 of 6. It's exactly the same as the example he used. Don't let the fact that there's numbers, 7 and 6, scare you.
Oh, and notice they're not using the term condense. They're saying write it as a single logarithm.
Oh,
okay. So I'm going to write my log notation with the base 4. Do I need a fraction bar? Yes, because of that minus sign. I agree. I'm going to need a fraction bar. What have I got on top? 7. Is there an exponent on that 7? Okay, what have we got on bottom? 6. Is there an exponent on the 6? There's the final answer.
Y'all can get 1 through 10 done. You'll be more than ready for class on Monday when we pick up doing more of this condensing. And then
type in the answer.
Let me type in the answer. I type log base 4, right arrow, and 7 over 6. Wouldn't it have been better if it had been a 12 instead of a 7? Because then you could actually divide. 12 over 6 would be 2. But, so, my little... You see, we'll do more of this single expression stuff the next time.
But look at that argument, that z plus 7.
Notice how they did
that
it.
Z plus 7 is in the argument of the original problem. That means z plus 7. It can't be split up. Z plus 7 must be in the argument of your final answer. We'll just pick up here the next time.
Okay, so try to do the work on these first 10. Because if you don't, you might forget between now and Monday. Okay, so any questions?